Let's look at the algorithm through a simple example of a network of 6 nodes from node A to node F. We begin by setting the starting node's weight to 0 and every other node's weight to infinity. We also keep track of the already visited nodes. First we compare the distance from node A to node B to the weight of the node B. Because the distance 2 is less than the weight of infinity, we set the weight of the node to 2. Then we do the same comparison on the node C. Because the weight of the node is greater than the distance, we update the weight to 4. Now we set node A as a visited node and move to the node B. We start by comparing the distance to node D to the weight of the node D. Since 6 is less than infinity, the weight of the node D is changed to 6. Then we compare the weight of the node E to the distance and update node E's weight to 4. Finally, we compare the distance to node C to the weight of the node C. Because the weight 4 is greater than the distance 3, we update node C's weight to 3. We mark node B as a visited node and move to node C. From node C, we can compare the distance only to node E, since nodes A and B have already been visited. Since the distance to node E is greater than the weight of the node, we mark node C as visited and move on to node E. From node E, we compare the distances to the nodes D and F, since nodes B and C have already been visited. That way we set node F's weight to 6. Finally, we visit node D, but since none of the distances are less than the weight of the node, no weights are updated. At node F, there are no unvisited nodes left, so we just set node F as visited. Now when all of the nodes are visited, we can see that the shortest path from node A to F is through nodes B and E, with the total distance of 6.